In this video, we are going to learn how to compare and order real numbers. Let's begin. So, comparing. We have a couple different signs we want to remember. This first one is called less than. Now remember, these two signs are not interchangeable. This one isn't less than or greater than. It's always going to be less than. If you want to remember which one is less than, you could think of it as kind of like, it's almost like an L. That's kind of 3D, or you're looking at it from an angle. Greater than is the first one, and greater than, it's eating the first number. So you can say this is, I'm going to write that down, greater than. This one, look at that, looks like that little L, less than, or equal to, is what this is, that little line. And finally, you've got greater than or equal to. Let's see if I can even fit this. Greater than or equal to. So what's the difference? Well, greater than or equal to and less than or equal to will include a number. Less than or greater than means strictly a number is going to be bigger or smaller than it. So values can be ordered from least to greatest or greatest to least. List some other keywords or phrases that can be used below. You can say smallest to biggest for least to greatest, but I'm not going to write that down. One that you might see that is a little bit more higher in the vocab is ascending order. Ascending order. Greatest to least, descending order. To descend is to go down. So you may see those words instead of greatest to least or least to greatest. Comparing or ordering. When comparing or ordering, it is helpful to represent the values in the same form. Practice converting between three forms of numbers below. I am going to be more specific. I think the best one to, if they're not all in decimal form or in percent form, I think it's, or in fractions with the same denominator, I think it's always best to convert them into decimal form. Okay, so let's go ahead and convert some of these. Remember, to turn a fraction to a decimal, you need to do division. So 1 divided by 3. Remember the rule. The rule is in, the top number goes in, and out. Bottom number goes out. So in, 1 goes in, 3 goes out. How many times 3 go into 1? 0 times. Add a decimal, add a 0. We have to add a decimal up there as well. How many times 3 go into 10? 3 times. 3 times 3 is 9. Subtract 1, you're left with 1. Add a 0, bring it down, and you're going to end up with 3 again, which means you have the same pattern. It's going to be 0.3 repeating. It may actually be really helpful if you just kind of memorize that 1/3 is 0.3 repeating, because that's a common one, and 2/3 is going to be 0.6 repeating. If you remember that, it's just going to make your life easier, because take a look over here, 2/3. If you do division on it, you're going to find that that's actually 0.6 repeating. Okay. We'll talk about the percents afterward, but, well, actually, we might as well talk about it now. So let's take a look at how do we turn a decimal to a percent. That one's easy. There's something called, you may have learned it, it's called dip, and this means decimal into percent. So dip means decimal into percent. And how does this acronym help us? It tells us whether we should move our decimal point to the right, or we should move it to the left first, or move it to the right first and to the left. Gosh, I'm getting my directions mixed up. Okay, so if you're trying to turn a decimal into a percent, you're going to dip 2 spaces to the right, and it's always going to be 2 spaces, 2 decimal points. So decimal into percent means you move the decimal point to the right. percent into decimal means you're moving it to the left. So let's say I had something like 1.5%, and I want to turn that into a decimal. That means I want to turn this percent into a decimal. That means I'm going backwards. Percent into decimal means I'm reading it backwards. I'm going left. So I'm going to move this 2 spaces to the left. Put it right there, which means my new decimal without the percentage sign is 0.015. However, if I wanted to turn a number like 1.6 into a percent, remember I'm going from decimal into percent, so that means I'm reading it forward. I'm going to the right. I'm going to dip or move 2 spaces to the right, which means new decimal is right here. I have to add a 0, and then what that means is 160%. All right, hopefully that makes sense. All right, so let's dip on this one. I have 0.3 repeating, which is 0.333. If I'm going to move my decimal over 2 spaces, because decimal into a percent moves over there, which means I get 33% or 33.3%. You can just leave it to the, it looks like they do 1 decimal point, so we might as well keep it consistent. Let's do 1 decimal point, 33.3%. All right, fraction. How do you turn a decimal into a fraction? Well, you're going to do it by putting it over. This is 2/10 right here. This is 2/10, which means I write 2/10. Now, I need to simplify this. You can divide both 2 and 10 by 2, so that actually is 1/5 is a better answer. 0.2, let's dip over 0.2, 2 spaces, which makes that 20%. All right, I now have 50% for this one. I need to turn 50% into a decimal. 50%, many of you already know that's 1/2, which is kind of nice. So 50% is 50. The decimal point would be right there. And if I want to turn a percent into a decimal, I'm reading it backwards. I'm reading dip backwards. That means I'm going to move the decimal point to the left. So move it 2 spaces to the left. And what that means is 50% is 0.50. Or 0.50, you don't really need to add that extra 0, 0.5. We talked about the 2/3 before, which is, if you memorize that 1/3 is 0.3, 2/3 is 0.6 repeating, which means this would be 66.6%, but it's 66666, so if you want to round it, it would actually go up to 66.7%. We have 0.75. Let's dip it to the right. So this is 75%. And then that would be 75 over 100. You can divide the top and the bottom by 5 or 25, really. That's 3/4, which is 3 over 4. You have 12.5%. It looks like you're going percent into decimal, which means you are going to percent into decimal, remember, which means you're reading it backwards, reading it from right to left. So you're moving this decimal to the left 2 spaces. 2 spaces, which gives us 0.125. And 0.125 is 125 thousandths. Oof, I don't know what that is off the top of my head, but I know 25 can go into 125, and it goes in 5 times. How many times does 25 go into 1,000? Well, it goes into 100 4 times. And it goes into 100 4 times, and there are 10 hundreds, so I would say it's probably 40, 5 over 40. And 5 goes into both 5 and 40, so that probably equals 1 over 8. 1 over 8. Sorry, that was not a very good 8. Let's see if I can draw a better one. 1 over 8 is going to be our final fraction. 2/5. 2/5. A couple different ways to do this, but let's go with the tried and true division. In and out. 2 goes in, 5 goes out. 5 does not go into 2, so we add a decimal. 5 does go into 20 4 times. and it goes in perfectly, so I'm not going to waste the rest of my time to do that. So it goes in 4 times. It's 0.4, which if we move the decimal 2 places over to the right, we have to add a 0, and it turns into 40%. And then we have 1.5 here, which is, let's move our decimal 2 places to the right, 1, 2, which means I have to add a 0, which gives me 150%. What is 1/5? Well, this is 1.5, right? 1.5 is 1.5, so it's a mixed number. It's 1 and 5/10, 1 and 5/10, or just 1.5. All right. So we're going to compare the following values on the next page by placing the correct inequality sign in the box. Okay, couple tricky things. Number 1, note that they are negative. Both of them are negative, so that's going to mess with makes it a little bit more confusing, but let's go ahead and start on this problem. I'm going to make my writing a little thinner. 7/8 and 0.5. I'm going to convert, rather than doing, well, I'm going to convert my fraction into a decimal. It makes it easier. So 7/8, in and out, 7 in, 8 out. 8 does not go into 7, but it does go into 70. It goes into 70 8 times, because 8 times 8 is 64. And do we really need to continue with this to find the exact decimal? We do not. It's roughly 0.8, or actually not 0.8, but negative 0.8. So I'm going to write above this negative 0.8 approximate, and that's good enough because we know that this is 1 decimal place, this is 1 decimal place. That's all you need to know. Let's take a look. Which one is greater, negative 0.8 or negative 0.5? Negative 0.5 is greater. Now, why is it greater? It's because we're talking about negatives. And remember, if you were to look at a number line, zeros here, you'd have like negative, let's think of that as 5, not 0.5, but negative 5 would be over there, and negative 8 would be over there. So 5, this number would be the greater number, okay? Because everything, when it comes to negatives, it's like you're in opposite world when it comes to comparing and ordering. All right, let's take a look at number 2. Same issue. We have square root of 50, which is an imperfect square. We have to estimate what 2 numbers is it between. Well, let's see. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Oh, that's pretty close. So radical 49, which is 7, and 8 times 8, which is 64, and that's 8. So radical 50, if radical 49 is right here, radical 64 is over there, radical 50 is like right over here, right over there. And what actual number would that be? That'd probably be like 7.1 or 7.0 something, but 7.1 is pretty close. Pi square, remember, that's pi is like 3.14, right? So it's 3.14 times 3.14, but do we really want to multiply all that craziness? Let's keep it simple. Let's just multiply 3 times 3 and see if it gets us close enough, because 3 is smaller than 3 times 0.14, so let's multiply that. 3 times 3 is actually, I don't even need to write that down. It's about 9. And 3 times 0.14 times 3.14, or 3.1 times 3.1 is maybe it's 9.3, 9.1. I'm not really sure. But it's 9 point something. It's roughly 9. And this is roughly 7. And you know what? That's enough information to decide which one is greater, pi square or radical 50. It's going to be pi square. Okay? Make sure you remember, pi square is not 2 times 3.14. No, that's like 6.28 or something. It's 3.14 times 3.14, which, you know, 9 is close enough. Let's look at number 3. Negative, remember, it's a negative, so, you know, it's like everything is opposite world. But let's fix these numbers first. 60, we're doing percent, we're doing dip. Remember, percent into decimal, which means we're going to move our decimal point to the left. So it starts here, it goes left 2 places, so this number is roughly negative 0.6 or negative 0.6. 3/4. Hopefully you just memorize that this is 0.75 or 0.75, negative 0.75. If not, you can do division and figure out that, well, let's do that just in case you didn't know. In is 3, out is 4. 4 does not go into 3. You add a decimal and a 0. How many times 4 go into 30? It goes in 7 times, because 4 times 7 is 28. We don't need to continue because we have 0.6 right here. We know this would be 0.7 something. Which one is greater? Remember, it's the opposite when we're talking negative, so 0.6 is greater because it's closer to the right, or it's further to the right. Finally, last one, 5 plus 60, radical 60, I mean, and then 4 plus 63. What is radical 60? Well, let's see, 8 times 8 is 64. So you've got 64 on one side, and that's 8. And 7 would be on the other side, and that would be 49. Gosh, that's 60 is closer to the 64 than it is to the 49. How much closer? Well, I don't know. Maybe it's 7.8, 7.7, 7.8, something like that. Hopefully that's close enough. Now, this is 7.8. You're going to add it to 5, which gives us like 12.8. Hopefully that's good enough information. Oh, look at this. This is 63, which, again, we discussed is closer to 64, 49. And so that's like right here. So if this is 7 and this is 8, then that's like 7.9. So we have 7.9 right here, and we have 4. And 4 plus 7.9 is 11.9. Look at that. We've got this versus that. Which one is greater? They're both positive, so 12.8 is greater than 11.9. Let's move down. List the following in descending order. Oh my goodness, this is a lot. Well, thankfully we did some of this already. This is roughly 9. Hopefully that's good enough. You don't have to put that squiggly, but it's 9 point something. Who cares what the rest is? Radical 11, that is a perfect square. That's, radical 121 is 11. 11.1 is 11.1. And then radical 130, well, that's going to be bigger than radical 121, but let's, for the sake of it, figure out what it is. 11 times 11 is 121. 12 times 12 is 144, so that's 11, and that's 12. 130 is probably in the middle of 11 of these two, so maybe it's 11.5. Good enough. I think we can list it in descending order. Descending mean going down from largest to smallest. Largest is 11.5, followed by 11.1, followed by 11, followed by 9. Let's go ahead and write the associated numbers because they are actually, if this was a multiple choice question, it would be written in these forms. So 11.5 is rad 130, followed by 11.1, which is 11.1, followed by 11, which is radical 121, followed by 9, which is pi squared. So that is our answer. Let's check out number 6. We got 2 more questions. So list the following in increasing order. Increasing meaning smallest to biggest. Should have written that down. Increasing order. Actually, probably still can right now. Increasing and decreasing. Should have said that earlier. Sorry about that, friends. So list in increasing order. This one's already good. It's 0.65. 6.5. Oh, that's easy. Percent to decimal. Remember, DIP is the acronym, and we're doing it backwards, so we're moving it 2 to the left. 1, 2, which if I had, I'm just going to do this. 6.5%, moving it 2 spaces. That means it goes right there. Real decimal. That's 0.065. All right, 2/3. We remembered that. That is, you can keep dividing, or you could just remember that this is 0.6 repeating. Or because it's 0.6 repeating, and this has 3 decimal places, it might be actually helpful to say, hey, this is 0.666 or 667. I don't think it will matter in the end. Let's just say 667 because we should. And finally, 1/2 is 0.5. All right. So which goes first? Which is the smallest? Well, it's this one is the smallest, I believe. Well, no, it's not. It looks the smallest, but I get confused. So let me write these down. I have 0.65. I have 0.065. I have 0.5. And, well, actually, 0.666 or 667 and 0.5. And you'll see why I got confused, because I'm like, oh, 5, that's the smallest, because, you know, everything else has a 6. It'll be helpful to add extra zeros so that they all look more similar. So there are 3 decimal places for the numbers. So this is what I'm going to do. Now it looks more similar. This looks like 650. This looks like 65, 667, and 500. Which is actually the smallest? It's the 65. And which one is the 65? It's the 6.5% is the smallest. So we mark that off. Which one is next after 65 is it 60, 650, 667, or 500? I'd say the 500, the 0.5, which is 1/2. What's next after the 1/2? Well, it is 0.65, which is 0.65. And finally, the largest is 2/3. Ascending order from smallest to biggest. 5.5. That's 5.5. Hopefully you knew that. 5.5. 26 radical. That is really close to radical 25. The next one is radical 26. 36. And radical 25 is 5. Radical 36 is 6. So radical 26 would be like right there. It's like 5.1. 5.8 is 5.8. And 31/5. 5 goes into 31 6 times. So you could do in and out. 31 divided by 5. Goes in 6 times. You end up with 30. You have a 1 left over, and you need to add a 0, which means we add a decimal. How many, and bring it down. How many times 5 go into 10? 2 times. Perfectly. I'm not going to bring down the 10 and subtract, so our answer is going to be 6.2. So, thankfully, they all have 1 decimal point, so it's easy to tell which one is the smallest. 5.1 is the smallest, so we are going to write that one first, which is radical 26. After 5.1 is 5.5, which is just 5.5. After 5.5 is 5.8, which is just 5.8. And after 5.8 is our last one, which is 31/5. Last question. Today's low temperature for 4 different towns is shown below. List the towns in ascending order. Remember, that means smallest to largest, least to greatest, according to their temperatures. So these are all negative, which again makes it crazier. Let's go figure out what radical 48 is. I'm going to do that over here. 48, let's see, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Oh, hey, look at that. Whoops. It is 36/49, which is 6 and 7. And 48, gosh, if it's really close to 7, but right below 7, this is more like 6.9. 65, radical 65. Well, that's higher for sure. How much higher? Let's take a look. 8 times 8 is 64. Oh my gosh, if 8 times 8, if radical 64 is 8 times 8, then radical 65 must be like 8.1. Negative 7.5 is negative 7.5. Oh yeah, forgot. These are all negative. Finally, negative 22 over 3. How many times 22 go into 3? Let's do a little bit of division. 22 goes into 3, or 3 goes into 22 7 times. And that gives us 21. We have 1 left over. And we add a decimal. This might be okay. Bring that down. 3 goes into 10 3 times. So we have 7 point, and we end up with a 9, and we end up with a 1. And then it just kind of keeps repeating. So 7.3, negative 7.3. I think that's enough information. Which one is the coldest? Ascending order, least to greatest. Least. Which one is the coldest place? Well, it's not negative 6.9. It's actually negative 8.1. So it would be Shiverton. Sorry, not Shiverton. It's Icetown, which is the coldest. Icetown. So afterward, it's the next one, which is Little Flake. No, not Little Flake. The next largest negative number is Shiverton. Followed by Little Flake. Followed by Chillyville. Whew, all right. So you may be thinking, this is really difficult. You are correct. There is a lot of work. It is very difficult. Hopefully you remember all your skills, you've retained them, and you'll be able to do this okay.